Hello, welcome to another stream. Welcome. Hello, yet another PS.com Psy, Apparently Potatoes, Kolumbetka, Beat69 Trim, Yatko Akloramis, hello, Searching Fox, welcome, Ivanho, hello, Sintus, hello. So yeah, welcome to another stream. So the day is Wednesday, if I'm not mistaken. Right, today is Wednesday. That means today, according to the schedule, I'm dying. Today we're keep doing Virtual Machine in C. Hello, Eat, Code, Sleep, Repeat. Welcome. So we continue. Wait, no, it's not the next one. It's I'm really tired today for some reason. I think, I just want to sleep and I just want to do nothing. But stream is live, so I'm streaming. You look tired. Thank you. You're so observant, Rotten Chauncey. You're absolutely incredible. Thank you so much for telling me that. Yes. So today is Wednesday, right? So, and today is virtual machine in C. Yesterday we were kind of working on a virtual machine in C, but not really. Yesterday we were experimenting with alternative build systems for our project, right? So, and the build system we came up with a simple header library that lets you use C as sort of a shell, and once you have a shell, you can run external commands from it and build things, right? So, yeah. So, and we almost done. So the build system actually does what we wanted to do, and we can even build the whole thing. But we haven't merged the pull request where we were experimenting with our thing. So I think the first part of the stream is going to be cleaning things up. I want to do that off screen, but I was really tired yesterday, so I couldn't finish it on off screen. So that means I'm going to be doing that on screen. Right, things that you can't do off screen, you have to do on screen. Make sense? Makes sense. Hopefully, makes sense. Luckily, I have a tea with me. So, yeah, I'm gonna pour a cup of tea. I'm gonna just drink a little bit more tea, and maybe we're gonna be good to go. So there we go. Cool. Oh, just a second, it doesn't fully. It has to be squeezed out really hard. Alrighty, so let's take a look what we have here. No screen coding. We'll miss nothing. Yes. Okay, so let me go to my project. And here it is, we have a lot of garbage in here. So the way it works, right, let me start Emacs from within the environment and whatnot. And so here is the build script. This is how it looks like. This is the build script. So essentially, it's literally a C program. It's literally a C program, and it has like three phases. It builds the toolchain, so it builds all the executables of the project, right? And it does that by iterating the array of the executables of the toolchain and invoking a special build C file function, which is different depending on the platform you're working on. Right, on Windows it's going to be calling cl.exe, on a non-Windows system it's going to be calling cc. And as far as I know, maybe cc is some sort of like a POSIX thing. Right, but it works on Mac OS, Linux, and FreeBSD. It will call this standard like a C compiler. Right, and then we build examples by iterating over all the files in the examples folder, right, and then calling the BOSM that we built as part of the toolchain. And then we run the tests by iterating through all of the examples and calling a special BMR command on each individual test. So, and yeah. So, and all of these utilities are implemented in build.h, right? And that's the main build tool that we were working on yesterday. And it is, by the way, cross-platform. Yes, it is cross-platform. It works on Linux, Windows, FreeBSD, macOS. Well, we haven't tested it on FreeBSD, but since it works on macOS, maybe we can claim that it works on FreeBSD. Including, it can be compiled with MSVC. Right, so it uses Win API, Win32 API in the places where appropriate. So we actually made it cross-platform, right? So, and essentially what that means that your script, your build script that you wrote in C is also going to be cross-platform. So it's going to work both on Linux, Windows, and stuff like that. Yeah, but all of that is just part of the branch that we haven't merged yet. The problem with this build tool, by the way, is that it's called build. Seriously, that's one of the main problems with this build tool. because the most logical executable for this thing would be to call it build. But we cannot call it build because usually you have a build folder where you keep all of your artifacts of the build. So that's why I cannot call it build, right? I cannot call it build. And ungoogleable maybe. So I was thinking how to call it. So one of the ideas I had on how to call this build tool, what the fuck is going on? Alright, on how to call it, is I was thinking to call it stage 2. Alright, right. Essentially, stage 1 is your compiler, right? Stage 1 is your compiler, and you use your compiler to build a stage 2, right? And then you use a stage 2 to build everything else. So, but this name, it's clever, right? It's kind of clever, but I think it's too complicated. The logic behind the name is too complicated, and the name is also kind of ugly, right? So that's why I'm not gonna call it like that. So in the spirit of Zoomer Technologies, I think what we should call this piece of technology is no build. I'm not even fucking joking. Yes, it's gonna be called no build. Yes. You know, like no SQL, serverless. So we live in an era of denial, right? So the era of denial, where the next generation of developers denies everything that the previous generation of developers have come up with, right? That's why we have no SQL, we have serverless, and now we have no build, right? So we are in the spirit of the era of denial, right? We are denying the build as the concept, and the build tool that denies the build as a concept, building as a concept, should be called no build. Makes sense? Chat, I'm asking you. Does it make sense? Okay. Doesn't make sense. Exactly. Thank you so much. But I need to call it something, so it has to be something, but like, you know, something that is not a build, right? Something that is not a build. And what's the best way to call it? No build, right? So, nope. The music is in fact too loud. Yes, I forgot to actually bring it down. All right. Compile me also not a bad idea, actually. But it's too late, I think. It's too late. Alright. So that's gonna be the go-to solution for our thing. So I need to remove some of this shit that we put around. Okay, no build. And it looks kind of it looks kind of cool in the folder, like it catches your eyes, like no build and stuff like that. All right. So yeah, and the way you have to use this entire thing, you have to do it like this. You build no build.c. And it doesn't work because we renamed everything. So now we have to call it no build.h. And now it works. So essentially you compiled the first stage, and then you use this first stage. Wait a second. I should have actually called it from the compile command. Yeah, to build everything else. Yeah, this is the output of that C program. Seriously, this is the output of that C program. It creates other folders, it runs the C compiler, it runs the other executables, and so on and so forth. And also, yeah, we need to fix this entire thing. And we can always rerun it. So, yeah. no build. Knob. Knob is also pretty good, I think. Alright, so I also accidentally almost saved. Yeah, I saved the compilation buffer for some reason, I don't know why. Alright, so and we also want to git ignore no build executable here, right? And now, what I want to do, I want to rename whatever we have here. So, yeah, first thing I want to do, fix the tests. Fix the tests. Yeah, this is what we did. And then I will do it like that. Rename. Maybe before I rename everything, I also have to go to the to my continuous integration, right? And we need to go to my continuous integration and just rename everything here accordingly as well. So this one is going to be no build, and what you're doing here, you're literally just running no build like this. So this is for GCC. Renator Bello, I hope I pronounced your name correctly. Thank you so much for Twitch Prime, your first subscription, by the way. Welcome, welcome, welcome to our epic no build club. How about that? Reject the build, go back to C. Cheers, by the way. And that's exactly what we're doing here, by the way. We're rejecting the build and we're going back to C. Alright, so another thing here, so Clang. We should also try that in Clang, I think. So the BM is gonna be the first adapter of this technology. First ever adapter of that technology. Isn't that amazing? I think it's gonna be goddamn amazing, mate. So this thing is literally the same everywhere, except Windows, because Windows is a special kind of operating system, am I right? So, and yeah, you build no build, and then you run no build.exe. So, Yezu Kawai Desu. That's right. Rename build no build. In the spirit of error of denial. No SQL, serverless, etc. Of the error of denial. Okay, cool. And let's push that right into the record. Yes, exactly. That's what it feels like, because it's literally the same on every fucking operating system ever created on planet Earth except single one. Like, what? What's up, Cool Wizard? Welcome to the stream. Hello, NHMech. Welcome everyone, and especially no IO before the bedtime. I would assume that you are no IO before bedtime is a Haskell, and to be fair, I have no idea why you're watching this stream, but I really appreciate you that you're still watching it. Anyway, so yes, oh shit, we have so many pull requests for BM. Holy fuck. Okay. Wait, MinGW. Bill Keck is back at it again. I don't know who's Bill Keck and who they are in the chat, but they adding MinGW support to each individual of my projects. I really talked about that, but I really appreciate it. So yeah, I think it's funny. Like they go through all of my projects and they just add MinGW support. I'm watching this from New Zealand. It's almost midnight here and almost Thursday. Nice. And on Thursday, we're gonna be doing Advent of Code in Haskell. Anyway, so while Advent of Code in Haskell is not here yet, let's enjoy a cozy stream in C. Am I right? Let's enjoy a cozy stream in C. I wonder what they exactly did. Are they trying to submit a pull request to Yeah, they're doing to build. Oh my god, dude. Like, okay. Choose and. God damn it. It's too late. Okay, so here's the policy. I'm gonna be doing the policy from now on. I do not accept any pull requests to not master. So here's gonna be the policy from now on. No pull requests to other branches except the masters. Because every time I'm starting to deal with this kind of pull requests, it's hella annoying to clean stuff afterwards. The workflow. Master, pull request to master. Pull request to master, pull request to master. Wait until I'm done. So if this thing is not merged into master, it is not done yet. Stop fixing the code that is not done yet. It's pointless to fix something that is not done, okay? Let's finalize everything. Once it's done, we can merge it to the master, and then we can try to fix it. Okay, this kind of pull request, I'm gonna straight up ignore it. Right, so this is the policy from now on. I'm really sorry, I'm not even looking into it. Rebase it, do whatever you want, only to the master, nothing else. Because I've been like burned by that so many times, don't want to deal with that anymore. Only master. Clip that. I think at some point I'm gonna just add that to the contribution policy. Yeah. So we have a contribution policy where I basically described like the main points that I expect from people. I think I'm gonna just, you know, add it there. But I'm definitely gonna forget about that. Maybe. Okay, so I think I have a to-do here. Okay. Extend contribution policy on PRs to non-master branches. No master price deserves. Okay. I see, you got me. So it's the era of Zoomer denial. Yeah. Reject master. Pull request to feature branches. Let's see. To-do channel, yeah, we're gonna have a to-do channel at some point. Alright. Okay. No build. And I already pushed everything, so this thing is already incompatible and whatnot, so yes. Alright, cool. Now, maybe it makes sense to update the README. So if you're on Windows, yeah. So let's update the quick start. Oh yeah, I had that 2 days ago where someone wanted me to change the base branch of the PR not to be master. Yeah, so it's a really bad practice. It's a really bad practice, in my opinion. Alright, so what we're doing here, we have to do gcc no build.c, or maybe like generally we can call it cc, or maybe just cc, right? And then you just do no build, right? And it builds everything for you, and then you can run this thing. So this is the stuff. So quick start. Build on Linux, macOS, FreeBSD, literally any OS on the planet Earth except Windows. Right. So you do it like that. Build on Windows, console, MSVC, Windows with MSVC. low key roast. Okay, so run VC Microsoft VC var, yeah. run this thing. Is there any documentation used from a command line? VC var all. Yeah. So I'm gonna literally just give the link to this entire thing. Run and then cell xz no build.c. Yeah. So this is how we're gonna do that. No build.exe. There we go. Except Windows with MSVC. I think, yeah, so this is a quite important note, because on Windows you can still have this kind of a style of building if you use WSL or MinGW or something like that. So this is specifically for this kind of like style of building. Okay, and then running examples, and I'm going to do it like this. Cool. So that's pretty cool. Yeah, and the entire build takes literally 2 lines of code, and it's kind of similar to AutoTools or CMake, because in AutoTools and CMake you also have 2 separate phases, configuration phase and build phase. So you can consider building the no build executable as a configuration phase, right? So, and then you just run this thing, and there you go, it just does everything for you. Of course, like as this tool becomes more and more sophisticated, it will need its own configuration phase, and maybe we'll add configuration like facilities to the library, to no build library, and I'm not sure how exactly we're gonna do it, but yeah. So yeah, and by the way, I'm not saying that no build tool right now is ready to replace like CMake or Make or anything like that, or even Shell. What I'm saying is that I've been working on it for 1 day. This is the 2nd day of me working on it, and it can already build BM, right? So it's good for building BM, right? But something that is good for building BM and as simple as let me show you. As simple as this is probably easy to extend to build more complex things. That's what I'm saying. It's just my hypothesis. I don't know if it will be ever good for anything except BM. This is my research project. As anything on my channel, I just do researches, just play with dumb stuff, and yeah, that's what I do here. So don't expect anything like super production ready for me. I'm just farting around, just like Dennis Clark. Dennis Clark style of development. Yes, that's what it is. He invented it. Simple virtual machine, blah blah blah. Okay. I just all the time play with them. Well, that's the point of recreational programming. That's the beauty of programming, and that's why we love it so much, right? So yeah, doing something useful for the clients is fucking boring. That's what it is. Nobody likes to do that. Everyone likes to play with random pieces of shit and just have fun. Anyway, yeah. So okay, let me see what we can do now. Document no build. Nice one. I'm really good at naming my projects, right? So nothing, something, no build. Just yeah. Some time ago, I wrote me a tool that reads TSV data, tab separated, okay, and produces a LaTeX table. It is really dumb, but I use it all the time. Yeah, I see. It's like also I created such thing as Snitch or Boomer, which is a zooming tool, and I also use them all the time, and I do consider them very dumb. Actually, also Suwon, I also think it's a very dumb thing, but I also use it every time. Holy shit! I actually use a lot of my small dumb programs all the time, but I don't notice that because they're sort of integrated into my workflow seamlessly. Holy shit. Yeah, Suwon, Boomer, Snitch, a bunch of extensions for Emacs. Yeah. Oh fuck, that's so cool. Anyway, so I'm actually using them. Interesting. Oh, and recently, by the way, so I did that on the call yesterday, right after the stream. I finally extracted my small subset of DRAND interface implementation for Windows into a separate library, so you can find it here. So for those who doesn't know, DRAND is a POSIX standard way of working with directories, right? So POSIX specifies this header, which imports a bunch of functions that let you open a directory, read the file names from that directory, and then, yeah, so essentially it basically lets you not read the files, but it lets you read directories, right, to know what's located in there. And you can use this thing, for example, to recursively traverse the directories or something like that, right? And it's a standard compliant, like, POSIX way of doing that. And of course, it is not implemented for Windows. So what I did, I implemented a small subset of DRAND for Windows. That implements like literally 3 functions only: open dir, read dir, and close dir, I think, right? It doesn't implement anything fancy apart from that, but it's usually enough for my goals. And basically the idea, if you have a piece of code that works with minirand, it will also work with a standard compliant drand. So that's sort of the premise of this library. So essentially, if you have a piece of code that traverses directories or just looks up something in the file system for a particular way, you make it work with minirand, and it's going to be working on all the POSIX systems, macOS, Linux, FreeBSD, and also on Windows because of the minirand. So yeah, and I actually use it already in 3 of my projects, believe it or not. I use it in both of my games, Nothing Something, and I also use it in No build tool. And it's actually super small. The cool thing about it is that it is small, right? It's like 100 lines of code, 100 plus lines of code. And it's a header-only library in STB style, so you can just include this library, and there you go, you have a small subset of DRAND on Windows. Implementing POSIX on Windows yet again. Well, I mean, you don't really have to do that. I already saw implementations of DRAND for Windows. It's just, this is a very small subset that you're probably gonna use in 90% of the cases, right? And it's a single file, it's a single header file that costs you nothing to just copy to the project, to your project. Like, it literally costs you almost nothing, right? And yeah, so code in a header file. Yes, there is a code in a header file, and this is because it's a STB style header only library. I really recommend you to read more about STB style header only libraries, because it's a very interesting way of distributing C libraries. Right, so essentially, like, it's a single file that contains both declarations and definitions for your library. So essentially, it's a header and C file simultaneously. And this is how it works. Let me show you. So it literally split into 2 sections. The first section is header, right? So here is the header, literally. And the implementation is hidden under minirand implementation. So if you include this header, just include this header, it will act like a header, and your program will not link because the implementations of these functions are not found. So what you have to do, you have to first define minirand implementation macro and then include it, so it will include both header and the C file, so you can link it properly. The reason why it is done like that, so you can decide where exactly the implementations of your functions will go, in which exactly translation unit they will go. Right, and in any other places where you need these functions, you can just include that header without implementations. You see? It is actually like a pretty cool approach that was tested extensively by hundreds of users, hundreds of software through these STB libraries. If you never heard about STB libraries, check it out. It's fucking awesome. The guy who invented this entire approach is fucking genius, seriously. It's amazing. And it simplifies the distribution and management of the dependencies in C++ projects dramatically. Alright. So, yeah, and this mini rent is the STB style, you know, header library, essentially. Makes sense? Hopefully it makes sense. Whew. My first cup of tea and I already feel better, right? So you can remember me at the beginning of the stream and now it's me after a cup of tea. You can see the difference. You can see the difference. Anyways. Alrighty, maybe we'll have to make another cup of tea at some point. So before I actually merge all of that, I would like to address some of the to-dos in the no build thingy, right? So to do, child fail is not properly reported on Windows. By the way, this thing definitely has to be called not build h exec, but rather no build exec. I think it will make more sense. There we go. Build, yeah, cool. No build exec. Oh, and another interesting thing, I think, like, I didn't quite like this style of functions. I think it would be better to maybe merge them together, right? So you have something like this, then you have something like this, and this is the implementation that you're gonna have here. Yeah, let's actually merge them. I think it's kind of a weird style. I don't know why I decided to go like that. Right. So yeah, on Windows you have one thing here. On Linux you have a different one. Not on Linux, but on POSIX rather. All right. So let me see. So one annoyance that I have right now with this build system is that if you change something within the build system, you have to rebuild the build system before you can rebuild the project, right? But I do have a couple of ideas for that. Some time ago, like I'm experimenting with this build system for quite some time already. I think I already mentioned that. And one of the ideas I had is that the build tool should be able to rebuild itself. I found another bug in BDB, gonna open another issue for that. Okay, sure, go ahead and do that. I think once I'm done with the build tool, I'm gonna go and start working on the virtual machine. Okay, so yeah, so this is the prototype. Actually, 16 months ago, I was thinking about this kind of approach for more than like a year, actually. But here we have a tool that on top of that rebuilds itself if the C file is modified. Right, it has a function that basically looks at the modified time of the source code file and the modified time of the executable, and if the modified time of the source code is bigger than the time of the executable, it tries to rebuild itself, and once it rebuilds itself, it reruns itself. It reruns a new version of itself. And it actually works. So the problem with this, I don't know how to do that on Windows yet. So, but yeah, the idea is going to be the following. You only need to compile the source code once, and then using special function, the source code can rebuild itself every time you run it. And so you never have to rebuild it. So literally, you have to do configuration phase only once, and everything else just picks it up itself and bootstrap itself and just manages itself. That's going to be the idea eventually, but not right now, because I have no idea how to do that on Windows. So build launcher, yeah, I suppose. Okay. So, and another thing I also wanted to do here is to go. Yeah, so we kind of have like a similar thing here. Right, I'm gonna include this stuff like that. Yes, Kawai deso. So Win32. Alright. Make a shell script to build system. Fired instantly. It defeats the purpose. Okay, it defeats the purpose. This is why nobody can make a good build tool. Because every time people encounter a problem with the build tool, they think, I'm gonna just write a shell script instead of actually solving the problem. And let's just duct tape it with a shell. You know, it's just easy. Yeah, and that's why we don't have a good tool. Yeah. Joke. Just because it's a joke, it doesn't mean it's funny. I'm sorry. Yeah, I figured that it's a joke. I'm sorry. I think I had too much tea. I'm sorry, Bitstream. Okay. And I was thinking about making another cup of tea. Should I make another cup of tea? Nah, I think I should wait because I think I'm gonna be too. Oh, right. Cool. Yeah. To be fair, the build tool itself actually builds very quickly, if you think about it. So this is how quickly it builds. Super fast. We can even check out the timing. So that's the build of the build tool. That's the build of the build tool, and then you rebuild the build tool, and you know the build tool actually takes some time to build the rest of the project. All right, so what we did here. All right. Refactor no build stuff a little bit. Okay, let's push that right into the reading. Disgusting, I'm sorry. Okay. No build.h. Build tool compilation has 6.5 FPS, yeah. Alright, let's actually start with a child file is not properly reported on Linux. Right, so essentially, if, for example, compilation build fails, right, we kind of want to stop the compilation process. I'm going to remove something from here, and let's try to rebuild everything. And you see, it fails, but it continues to run things, right? So what we want in this particular case is to crash everything, right? We want to crash everything. Or maybe it's going to be some sort of a configuration thing. Yeah, so because what I was thinking about having a special macro. You see how it logs everything it does? You see how it logs everything it does? I was thinking if you don't like that, you will be able to do something like this. So you include that, then define no build, no echo. You know, similar to how, you know, you do echo off. Yeah, exactly. Maybe we can even call it echo off, but it doesn't look good. I think no echo is going to be better. So similarly, you can do something like define no build, no fail, right? Or no stop on fail, right? So essentially it's going to be an option. So whether you want to stop when something fails or don't want to stop when something fails, it could be something like that. You see what I mean? Yeah. And speaking of, I think I want to implement no build and no echo right now. I think it's going to be kind of cool. And it's going to be kind of a chill thing to implement. Or maybe I'm actually yak shaving. Yeah, let's actually put it to do for that. Alright, so it's gonna be to do. No way to disable echo in no build scripts. You could define this when calling GCC on the command line. What? You could define this when calling GCC on the command. Oh yeah, that's true actually. Oh shit, that's actually pretty cool. What's the flag for that in make? Ignore errors? I don't remember. Yeah, but in shell, for example, I think you do something like set -e, right? So I think it's the other way around. It's actually on by default, and if you want to fail when something fails, you set -e or something. And both hello. Alright, so no way to disable echo in non-build scripts, and yeah. to do, no way to ignore fails, right? And alrighty. So let's take a look at the to-do, and let's start working on that. So essentially, we have a function wait, right? And function wait waits for the children, right? So let's actually read more about this function. So all these system calls are used to wait for state changes in a child of the calling process. So to know what exactly happened with the status of a child, we have to provide a pointer to W status. So let's actually allocate it here on the stack, right? It's going to be W status, and once you have this W status, you have a bunch of macros to check what exactly happened, right? So you can check whether the process was exited, and if it was exited, you can check its exit status. But it may not be exited. It could be killed by a signal. So, and for this kind of cases, you have if signaled, right? And if you know that it was signaled, you can check out what signal was used to, kill the process. On top of that, it may be stopped, right? Or resumed, or resumed, right? So essentially, if it was stopped or resumed, I think we shouldn't fail, right? I think if our child process was stopped or resumed, we have to keep waiting for them, right? We only should declare a failure if the process was exited or signaled. Yes, so we're gonna look specifically for these two. For anything else, we can safely ignore that. Like, it's none of our business if the child was stopped for a while and then resumed. It's up to the user of that, of that program to decide what the fuck to do with all of that. We're only waiting for exit or signal. I think it does make sense. All right. All right. So, and I guess because of that, it kind of makes sense to do that in a loop. Right, so we can start an infinite loop like this, right? So, and we're only gonna break out of the loop that loop if we, exit it. If exited status. Okay, bye bye, Red Insurance. See you around. All right. So if exited, we have to print some stuff. It's gonna be something like error. Oh, and it actually will depend on whether the exit status was 0 or not. Right, exit status. And if exit status was not equal to 0, we'll have to, fail miserably. Exit status. Wife excited. No, it's actually wife excited. What was that supposed to mean? Cozy White Bear, hello, welcome to the stream. Wife excited. I want to make a cup of tea, by the way. What's up? Big connect. Maybe I'm gonna do a little bit more. Okay, so I'm gonna save the exit status to here. Exit status. If exit status not equal 0, we'll have to do fprintf std error. Error child exited with D exit status sadge. Nah, I'm not gonna put sadge. Alright, and we're gonna provide the exit status like this. And do we want to exit with the child's exit status? Or we just want to exit with something else? I don't think it makes sense because we don't know which child actually exited. So I think I'm gonna just do like -1 in that case, right? So if we're gonna exit with the child's exit status, it's not gonna be useful for us anyway because the caller of this program doesn't really know which child actually died, so whatever. Yeah. With exit status, sadly, it feels like real life problems. Yeah. So, next thing, exit status and if signaled. So no matter what was the exit status, we break out of the loop, that loop. Now, if the child was signaled, right? W status. If the child was signaled, we should die. Regardless of the signal, right? We should die regardless of the signal. If I understand correctly, of course. STD error. Error. Child process was terminated by the signal, and we're gonna just provide the signal. Term sig W status, and then we're just gonna do exit -1. Yep, cool. So yeah, that should be enough. So essentially we spawn a child and we keep polling its status, keep waiting for its status, and we only stop doing that if it exited or signaled. And we only continue execution if the exit status of the child was 0. I think it does make sense. Child was terminated. Yeah, it is what it is, chat, and it isn't what it isn't. Alright, so that should be working, and let's go here and try to do some sort of a fucky-wucky. And maybe even oopsie-doopsie. So I'm gonna just remove a semicolon. Alright, and there we go. Child exited with 1 exit status. With exit... what? Exit code. What the fuck is wrong with me? Yeah, so... and... is that even a good message? Is that even a good message? So... we can try something like maybe command would be better. Yeah, command would be better because that's exactly what's going on. So because yeah, command exit with maybe exit code 1, but yeah. So first you see the command that was executed, right? You can clearly see the command. And then you see the output of that command, and then you can see the message from the no build telling you what exactly happened. Compilation exited abnormally. Yeah. Well, I mean, we could have used that. You know, command. Yeah. Bike shedding. Bike shedding. Chat, why are you bike shedding me? Stop bike shedding me. Alright, so then you can go here and you can rebuild everything and everything looks okay. Nice. And what's important, what it is important for is for testing, right? So for example, you have some test cases, and for example, testing fails, and we want our build to fail as well, right? So, you know, build failed here, and yeah. So now I fix that. And rebuilds everything. Starts shading his bike. Okay. Nice. Okay. So handle command failures on Linux. Right, and I'm gonna push that right into the repo, but before I push that right into the repo, I'm gonna also break the tests just to see if it does exactly what I wanted to do on CI, right, because it's quite important. Break the tests to see if the command failures on Linux work correctly. Let's push that right in the repo. And while we're waiting for continuous integration, I'm gonna make a cup of tea. I'm gonna make a cup of tea. When I was working with BM, I couldn't tell who wrote errors at first glance, BM or compiler. I used to dank error messages of Sodium project. Dank? What? Excuse me? VM or compiler? All right. So, okay, we're waiting for continuous integration and stuff. So hopefully it will fail. Okay, so it fails on all of the POSIX systems. Let's take a look at what exactly it says. Is it enough? Hopefully it's enough. Reading database. I don't use database in my project. What the fuck? Oh, it's installing third-party dependencies. Yes, I see. So, and I wonder how we're gonna implement that on Windows. Right, on Windows we use spawn, right, and spawn. I guess it depends on what it returns, depending on the result status and stuff like that. Yeah, this is exactly what I wanted to see. This is exactly what I wanted to see. And look, Windows doesn't fail, right? Windows didn't fail because we don't handle that stuff properly. So let's actually learn how to handle that properly on Windows. So here it is. Because if the tests fail, I want it to fail the continuous integration as well. It is very important. So return value. The return value from asynchronous call is the exit status of the new process. The return value from an asynchronous is a process handle. Okay, that's actually pretty straightforward. You can set the exit status to non-zero value if the spawn process specifically uses non-zero. Which of this function create new process to execute? Right. If the exit status is 0, the process terminates normally. You can set the exit status to non-zero value if spawn process specifically uses non-zero argument. If the new process is not explicitly set a positive value indicates an error. The new process is not started. In this case, error no is set one of the following values. Okay, that's cool. I see. I see. All right. Makes sense. So essentially what we have to do here, so it returns what? It returns int pointer t. Wait a second, is int pointer t a standard thing? Or is it... It's a C99 thing. Signed integer type capable of holding a pointer. Ha! That is very interesting. I didn't know that. So essentially you can have functions that sometimes return integer, but in some circumstances this integer could be reinterpreted as a pointer to something. So it's like a variant that holds both pointer and integer. That's pretty cool. Alrighty. So it's int pointer t, status. So could not execute, could not start child process, and error no explains something like this here. If the status not equals 0, right? Could be just greater than 0, I suppose. fprintf std error. That's gonna be error. Command exit with exit code, and we can provide the exit code in that particular case. Yes, and it's gonna be just a status, and then we're gonna exit with 1. So hopefully that will work as intended on Windows. We'll see about that. We'll see about that. So let's rebuild this entire thing and see if I didn't break anything. Alright, so cool. Try to handle command failures on Windows, and let's push that right into the repo. So, and while we're waiting for continuous integration, so now continuous integration should fail on both POSIX systems and Windows systems. While we're waiting for that, I'm gonna go to the kitchen and boil up some water. Don't go anywhere, or otherwise I'm gonna fail your Windows build, alright? Hello. Welcome back. Now, let's continue. Is it going? Is it working? Is it twerking? So this is contribution rules. This is some other stuff. I have a lot of shit open, to be fair, so I think I'm gonna go and just close all of that. Yes, I think it's... Hopefully it failed. It failed on all of them. Okay, this is perfect. So it failed on POSIX systems, and on POSIX systems it failed because the yeah, command exited with the exit status code. Perfect. Windows. Let's take a look at Windows. And for fuck's sake, this is such a bad interface. It tries to scroll around and shit like that. So exit 1, and yes, this is perfect. This is actually perfect. Now I'm gonna go ahead and fix the build. Right, I'm gonna fix the build. Yep. So this one is gonna be 9. And me fixing that test build should fix the build on all of the platforms simultaneously. So let's see how it's gonna go. Fix the tests. This should fix the build on all of the supported platforms at the same time. I'm saying at the same time because I don't know how to spell simultaneously. At the same time, if I did everything correctly. Alright. Okay, I think my water is ready, so just a second. Alrighty. Let's continue. Oh shit, I'm sorry. Lori Master, what the fuck?
Don't forget to check if your Prime token is available.
Prime token? I'm not sure what you mean by that, but thank you so much for 19 months of Twitch Prime subscription. Thank you, and welcome to our epic No Build Club. So I don't know what is a Prime token. Is that something related to Amazon Prime? I didn't use Amazon, I'm sorry. So I have no idea what the fuck is that. So yeah, it's kind of weird. But thank you so much. 19 months. Holy shit. Another one? Free subscription with Twitch Prime Gaming. Okay. Thank you, Raven Master, for 16 months of Twitch Prime subscription. Thank you, and welcome to our epic No Build Club. That's right. Welcome. Thank you, everyone, for such a generous support. Old9, hello, Old9. Welcome to the stream. Alrighty. So, what do we get? Did I push everything? I don't remember if I pushed anything. I'm gonna sneeze. Holy fuck, I'm gonna fucking sneeze. Thank you. Thank you so much. Okay. So, and it fixed the build. Look at that. It fixed the build. We implemented that functionality. So, essentially, in no build, right, if the command that you execute fails, it's gonna fail the whole build, right? It's gonna fail the whole build, and we handle that on all of the platforms. So that's pretty pogue, not gonna lie. Anyway, so do we need anything else? I guess that's it. I guess we can just well, it depends, right? So it depends actually. Yeah, I want to get rid of all of the scripts. So we double checked. We can build on Windows. We know that for sure we can build on Windows, so I'm removing this script. Right, so no build msvc.bat anymore, okay? Build.sh, we can build on, so basically no build already has the functionality of that script. We don't need that script anymore. This one is interesting, right? So we want to have that functionality within no build. So let's go. Let's do something like build x86-64 examples, right? So it's going to be something like void, and of course, this is going to be something like this. There we go. Yes. Oh, so okay, it works on FreeBSD. You tested it. Nice. So okay? This is actually pretty cool. I really like that it works on FreeBSD. Holy shit! It's so fucking awesome, mate. Fucking awesome. So essentially, let's just do it like that. So we have, oh shit, and you need a redirect functionality. Fuck. Yes. Okay, so this is actually very interesting. How are we gonna even do that? A redirect functionality. Well, I mean, yeah, we just need to go ahead and implement that at some point. It's not coffee, by the way. It's an oversteeped tea. That's what it is. And I do brew my tea in a French press. Assume it. All right. So let me see. So obviously we use something like command, right? We use something like command, and chifir. Well, I mean it's accidental chifir, okay? Don't judge me. It was accidental. Bin. And then we do bosom to NASM, right? So we execute this command and we provide this thing as the input. So it's going to be examples 123i bosom, right? 123i bosom. And well, we can always, like, you know, do something about that. So we can have a separate script like cmd with a redirect to output, right? Cmd out file, right? Out file, and you can provide where exactly you want to output it, right? So, but how is it gonna even work? So do you have to provide that as a first argument. I think because of the limitations of the macros, I think it has to be the first argument. I think it has to be the first one. Alright, so let me path like this. And it kind of looks weird, but it is what it is. Right, it is what it is. So I do know how to redirect output files to, like, on Linux. I have no idea how to do that on Windows, to be fair. And the question is, can it be done using the spawn command? So no build.h spawn like this. Let me read more about this kind of stuff. Output set printf count output. And what's funny is that if you want to collect this entire stuff, right? If you want to collect this entire stuff, it could be probably more difficult. Okay, so I have an idea. So we're gonna make it a to-do, right? Because I don't really want to spend time on working on it right now, because it needs to be properly designed and whatnot. So let's just put it to do here. And I'm gonna change BOSM to NASM to accept the output file functionality. So it will save it to the file itself. So we don't need to have output. All right. So there is no way to redirect the output of CMD to a file, right? It would be also interesting to have like some sort of a piping functionality, right, where you could pipe commands together and make it work on both Windows and Linux. I think that would be actually pretty cool. But yeah. So let's go to BOSM, right? BOSM to NASM, blah blah blah. And so you have to provide the output, right? So you have to provide the input, and in our case you also have to provide the output. It's gonna be output ASM, right? Output ASM. All right. So where is the shift? Do I have shift? Yeah, so let's put it here. And we're gonna do argc, then argv. Skip the program. If argc equals 0, right, it's going to be usage, std error, error, no input provided. Okay. So, and the input, const char input file path argv1. Cool. If argc equals 0, we're gonna do a similar thing. And we're gonna put it here. No output provided. No output provided. Output file path argv. Wait a second, I'm an idiot. So we have to use shift in here. We have to use shift in here. You have to use shift in here. Okay, so we have input and we have output. Nice. So then I use input file path, right? Input file path to load, to translate everything. And now I need to open the output file path. So it's going to be file output fopen output file path and a read binary. So if output is equal to null, right? If it's equal to null, we're gonna throw an error. fprintf std error could not open file. We provide the file path, and we also provide the explanation of what exactly happened. Output file path str error no, and exit 1. Cool. So, but now we have to do a very nasty thing. So we have to go through all of these printfs and replace them with fprintf. But I think with a little bit of Emacs magic, we should be able to do that quite fucking easily. Are you guys ready? So query replace printf fprintf output space boom. Oh shit. Okay. Yeah, I should have actually replaced this thing. Okay, it works. Okay. It worked. Absolutely fucking beautiful. So now, so now we have fprintfs here, everywhere, hopefully. Of course, if I didn't fuck up something, but we'll see if I actually fucked up something. Here we have to close the file. We don't really have to close it because it's going to be closed by for us automatically anyway. But we might close it anyway, just because we're good citizens. So, alright, so let's try to build this entire stuff. Okay, so it doesn't compile because, yeah, we don't have this shit. Let's remove it for now. Alright, so everything seems to be compiling. Did we even build Basm to Nazm? Yeah, we did build it. Okay. It's a Vim. You see? It says Vim here, so... Yeah, I'm using Vim. On Windows, you can't be sure it will be closed, though. Oh, makes sense. Yeah. Thank you. Thank you for reminding me. I kind of want to, like, program entirely... Like, start a project to program purely in Win32 API. Just to sort of recover that skill, because the last time I like seriously programmed in Win32 API, I was in high school or something like that. It was a really long time ago. Holy shit. Yeah, I kind of want to remember those times and just program in Win32 API yet again. Yeah. Anyways. Yeah, I was actually programming in Windows XP for Windows XP. Alright. Using LSW, aka Wine? Maybe. I was trying to set up development environment with Wine and I couldn't succeed. So I was more thinking about like installing an actual Windows and streaming for an actual Windows. I don't know if I'll ever find motivation to do that, but it's just something at the back of my head that I, you know, keep thinking about. Would be kind of cool. Yeah. Anyway, so let's continue. So here's this thing. And yeah, so now to build examples, you don't really need this kind of shit. So you just need to do... Oh, by the way, how to check that we are on Linux? Index of all... I'm not sure if it contains this thing. Predefined constants. Wait a second. I don't think it's a safe thing for me to do. Alright. C preprocessor check if Linux. How do I check OS with the preprocessor directive? This is a good one. Yeah, something like this. Yeah. Unix, Linux. Okay, thank you so much, Shunabeth. Thank you. So essentially, I only want to do this kind of stuff on Linux. If def and if not even on Mac OS or FreeBSD, because this kind of stuff is not supported on these platforms yet. So yeah, build x86 64 examples, and in here we're gonna do path build bin bosom to NASM, right? And then it's gonna be path build examples, and what example we want to build? We want to build 1 to 3 I bosom. So this is the input, and the output is going to be build examples 1 to 3 I ASM. So that's basically what's going to happen here. Supported mechanism. How am I going to use it? When you're going to use it when it's supported. So we're talking about a functionality that takes bytecode of the virtual machine and translates it to x86-64 assembly that uses Linux syscalls. Right. So yeah, of course, this kind of stuff is not going to work on anything but Linux. Maybe it's, yeah, it will work on FreeBSD with a Linux compatibility layer or something, but maybe macOS also has it. So yeah, but eventually we're gonna implement support for everything. Okay, it does work. By the way, does macOS have that Linux compatibility layers from FreeBSD? I don't remember if I actually asked that question, but yeah, except for the segfaults. Yeah, this is because some of the instructions are not implemented. That's why it's segfaults. So yeah, we just need to go and implement all the instructions, and then it's gonna work. I don't think so. Why? I think it would make sense, right? So basically, it just makes it possible to just take Linux applications and run them on macOS. Like, that's really strange. Was Apple sort of afraid of some sort of like a licensing issue or something? So it's really interesting. So maybe they were afraid that if you run GPL applications through that compatibility layer, that GPL license will infect their software. I don't think so, actually. It sounds crazy, but I don't know. Because anyone can just download GPL software on their machine, macOS machine, and just run it. Like, what's the reason to not include that? I don't know. It's kind of strange, not gonna lie. Alright, so let's actually try to run this entire thing and see if it's gonna work. Okay, bosom to NASM could not read file, bosom no such file. Okay, this is because it's not located in the build. So let's actually quickly remove that. Could not open file, no such thing. Okay. So I think I fucked up opening the file. Imagine fucking up opening the file. I opened the output file for reading. Output. RB. Every time you feel bad about your coding skills, just remember this moment. Clip that. And every time you feel bad because you cannot solve a nasty bug, just open that clip and watch at this shit. You're gonna feel better. GPL will infect their software. macOS must continue wholly no GPL BS. Yeah, I see. Something that I would do. Yeah. But at least I handled the errors, so it crashed the application. And this is why it is important to handle this kind of errors, right? Because if I didn't handle that, it would continue trying to write, and it wouldn't write anything. So yeah. Well, I mean, it would be also kind of nice to handle errors here, but I mean, I think it's too much work. So anyway, okay, so and it generated the ASM file, and if I try to find this file, and there we go, here it is, it got generated. So we can even remove this entire folder. So here is the build. So we generate quite a lot of shit here. Okay. Who did your artworks? I did them myself. All right. So cool. All right. So the next step we have to do, we need to link this entire thing. Hello, Squad Monkey. I hope I'm pronouncing your name correctly. Welcome. build x86-64. They're really good. Well, yeah, I used to be good at art. I haven't practiced for a while, so I'm actually a little bit rusty. So I'm not sure if I'll be able to draw this kind of art today. But maybe with a little bit of practice I can recover my skills. So we'll see eventually. Ahaha, rusty! Aha! Yeah, I know. So F. We're using dwarf. And then also -G. Okay, so here are all of the flags, and then I do path. Might as well actually just grab this kind of stuff. Talented? That's insulting. I spent like several years practicing to get to that level. And you calling me just talented? Really? What about all of that hard work and sleepless night that I spent and all of the thousands uncountable attempts? That doesn't count, right? Just talented. Seriously? Come on. All of that doesn't matter. You're just talented. Sure. Thank you very much. I really appreciate it. Okay, so here's the path. All right. So here's that, and should work again. So after that, we're trying to build the O file, and let's see how it's gonna go. So here's that, and here's the NASM. All right, and we need to now link this entire stuff. We need to now link it. So it's gonna be CMD, LD, O, and I think I'm gonna do it like this. So it's gonna be XZ. Look, it's building. God damn it. So this is output, but the input is gonna be slightly different, right? So the input, yeah, I'm gonna put it like that. The input is O. So yeah, to build this assembly thing, first you need to take the BASM file and translate it to assembly. Then you have to compile it to Object-Elf file and then link it into the executable. So that's how we're gonna go about that. All right, but this is only for a single example. And yep. So, but we have to now repeat it for several examples here. So because of that, we need to have a separate function. I want to like extract this to a function that accepts the name of the example and then just builds that specific example. Then I'm going to have the list of supported examples that can be translated to x86-64 and then just iterate over the array of those things. So build x86-64 example, and it's gonna accept example, like literally example name. So now I'm gonna just copy paste this entire thing here, and in the places where we use this thing, I'm going to basically replace that stuff with example, concat example, all right, and then just something like this. Cool. Now, in here, I can do build x86-64 example, and it's going to be 123i, and it will build that specific example. And if I want to build another example, I will just add another call. But let's see if this entire thing compiles at all. All right, so it built that specific example, so I can now try to build a Fibonacci one. So yeah. That's pretty cool. So as you can see, you can extract all of that to separate functions. Well, I mean, you can do that in shell as well, but We don't depend on chat. So I don't know. So I was thinking whether I want to introduce like an array of supported examples here. I don't think I'm gonna be doing that. Yeah, I think it's gonna be enough here. So pretty cool. And if I try to run one of the examples, right, one of the examples like for Fibonacci XZ, it also segfaults for me as well, right? So it also segfaults. It's not only for FreeBSD or like, you know, any other Linuxes, right? And we only build that on Linux, right? Because it's only buildable on Linux. Oh, and by the way, in here, I had a to-do. Not all of the examples are translatable with EAS, so this is kind of a to-do that needs to be put here. And since now we build everything, I can easily remove. I wish I could open the script. It's kind of difficult to open it, but yeah, I can now remove the script completely. So we don't have shit ton of different scripts anymore. Well, we do still have a record tests and run tests, so this is something that we'll have to address. Would you recommend Rust to a student who was constantly coding stuff in C/C++? Yes. I've heard about this language multiple times, but most of the people who were praising it didn't really write in it at all. I recommend, if you have a C/C++ background and you know C/C++ lore really well, meaning that you kind of understand why C++ was introduced and what are the main differences between C and C++ and what kind of problems C++ fixes in C, and what kind of new problems it introduces into C, I do recommend you to take a look at Rust. Whether I recommend you to abandon C/C++, I wouldn't recommend that, but I do recommend you to take a look at that language with your background, with the background that I just described. You will find this language interesting, you will find this language useful, and probably learn something new. Make sense? Right. So the problem with Rust is that majority of the things in Rust don't make any sense unless you know C/C++ a little bit and do understand the problems that are basically circulating in those languages. Right. So once you know this kind of lore, a lot of things in Rust starts to make sense. I would also recommend to have a little bit of a functional programming background. But I don't think it's necessary. I think this kind of background could be optional to, you know, to learn something new from Rust. Why does the FAQ says you usually use Emacs but you're using Vim today? Well, exactly because of that. I usually use Emacs unless I don't, and there we go, I don't use Emacs. Where is the contradiction? Literally no contradiction whatsoever. So I know C and Rust doesn't make sense for me. This is because you don't know C++. Do you know C++? No, you don't, because you hate it. But why today? Today is a Vim day. That's right. Anyways. Thank you. Great. You're welcome. So it's just, I don't know. I don't really know the specifics of your background. Like whether you're gonna find anything interesting in Rust greatly depends on your background. Seriously, right? So yeah, it requires like a very specific background to appreciate that language. And that background is really weird. So you have to have background with C++ and also a little bit of Haskell, right? So if you programmed in both of these languages, you will find Rust interesting. But even if you didn't program in Haskell, you will still find Rust interesting, and maybe it will, you know, help you to get into Haskell or something. Where are you actually from? Your accent is pretty similar to Russian or something like that. I'm from America. I was born in America, I was raised in America. I'm from America. That's right. This is my American accent. Hell yeah, brother. Fuck yeah, freedom. I love freedom. Comrades. Alright, so, yeah, what are we doing? Oh yeah, I forgot to actually do the test recording. I forgot to do the test recording. So it would be kind of cool if we had subcommands. Yes, so the time has come, chat, to introduce subcommands into our build tool. So essentially we're gonna have like test thingy. Like you would be able to do something like no build test, and it will run tests. Yeah, it's actually a pretty interesting idea, not gonna lie. So build tool chain. I'm from America, brother. Yes. Hell yeah, brother. Freedom. Alright. So what do we have? So everything seems to be okay. So this is the run tests. That means I can easily remove this thing, right? I can easily remove this thing. But I don't have record test, so I think I'll need to translate that thing as well. Yesu, 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 kawaii desu. Each being from the US of A. We're all living in America. America. Okay. So here's the run tests. Where are the run tests? Run tests. And we're gonna introduce. Oh gosh, fuck. Rammstein, please don't DMCA me. I'm never gonna be singing your songs ever again. Please do not DMCA. Can you get DMCA from this thing? I think on YouTube it's a thing, but I'm not sure. All right, record tests. Yeah. No, it's fair use. No, some sort of a parody, probably. Okay. So what we need to do here, we need to remove a folder. Oh, shut. We need to rem dir. Dirs? Maybe rm dir. And what we need to do here is to remove the the tests, the test. That's what we can try to do here, and then we can create directories. Have you heard about CS50 course? Is it good for start? I heard about it. I think I saw CS50 related stuff on Twitch, but I didn't really look into it. I don't know. Examples. Oh, there we go. So we remove this thing and then we recreate folders. And then we need to iterate through all of these folders, I think. So this is running the tests. And I think the only difference here is that, so it's literally the same loop, but the only difference here is that we changed the flag here. So it's now a actual output, and this is how it basically resets all of the tests. So the only problem here is that our mdir is not implemented for us, unfortunately. So if I try to build this entire thing, I mean, I need to rebuild the tool. GCC no build C, and then no build. Okay, so we don't have a mdir. All right. So no build.h. So we make mkdirs. We can introduce something like rmdir. So it's gonna be path rm dir impl path. So, and how do you remove a directory on Linux? So, okay, on Linux it's actually pretty straightforward, which must be empty. Oh shit. Do I really have to? Okay. I guess the recursion time, right? Some sort of recursion time. All right, rm dir impl const char path, and it's gonna be if def win32, right? So this is what we're gonna have here. It's gonna be one thing, and then it's gonna be another thing. Okay, how do you remove a folder on Windows? Win32 API remove directory. Let's see. Remove directory A. The path to be removed, the path must specify an empty directory, and the calling process must have. Okay, so. All right. Well, it's pretty much the same, right? So what I'm thinking about is we already use drent, right? We already use drent. We can implement a special function that iterates recursively over everything and just removes everything. That would be actually kind of interesting idea. But maybe for now, it's not really that important because we don't really need to remove anything right now. So why do we have so many questions that are FAQ? Right, so do we have a lot of new people here? Because like literally, I think it's like third question that is addressed in FAQ. Guys, check out FAQ. Do you really think like this is the first time you're asking this question? Come on. We have an FAQ page with all of the questions. Seriously. Alright. There is no way to remove a folder. Alright. Cool. So, but for now, to record the tests, right, we don't really need to do that. I'm looking at the wrong thing. No build. Okay, so we can just recreate this entire thing, and we probably don't even have to do it like that. Yeah. Okay, maybe even that is not needed at all. And also I want to add another to do here. No build.h. There is no way to remove a file, right? So all of this stuff is going to be very useful. But to record the tests, we just need to iterate through this entire things and just update them. Cool. All right, so I think the time has come to introduce subcommands. Right, let's try to introduce subcommands. So we're gonna have something like int argc char argv, and I think I'm gonna include the shift thingy into the build because I think it's quite important here. So it's gonna be bosom. So this is the shift. So we're gonna put it here, and it's gonna be like that. No build C. All right. So it's gonna be shift argc argv. Then if argc is greater than 1, So one of the things we always try to do, we're gonna always try to build the toolchain and the examples. We always try to build toolchain and examples. Then, if you also specified a subcommand, it depends on what kind of the subcommand. Okay, subcommand shift argc argv. Right. If strcmd subcommand is a test, right, we're gonna just run the tests then. Run tests. strcmd subcommand. What else do we have here? Record tests. Record. Let's call it record. Record tests. Like this. strcmp subcommand x86 664. Alright, and we're gonna move this entire thing here. So this is the build tool here. Cool. So let me see. Cool. So now if you just run the build tool, this is what happens. Right. If you try to run the tests on top of building everything, it should also run the test, but I don't think it did. I don't think it did, which is kind of strange. Did it fuck up something? I think it fucked up something. Yeah, maybe I forgot to rebuild it. So if I try to run it one more time, right? Is it gonna do the tests? Huh. Excuse me? It didn't run the tests, so oh boy. So let me try to I'm just sure, because it has to be greater than 0 because we're modifying, and of course then I have to do all this stuff. Okay, so I'm already created. Okay, cool. So now it works. So here's the tests, and you can try to record them. So it will rebuild everything, and it will also re-record everything. And on top of that, we can try to run x86 64. Yeah, so yeah, now we have subcommands, which is kind of cool. And on top of that, maybe it makes sense to have something like this. std error, unknown subcommand, something like this. Subcommand, and then we're gonna do exit one. There we go. So if you provide some garbage, it's what's funny is that it will try to build everything, and only then it will complain. So known subcommand, blah blah blah. Cool. Nice. So that's pretty dope. And because of that, we have to change the way we run all of that on CI. Right, on CI we do build, and we have to do tests now. So we're gonna do test, then test, and then here we also have to do test. But interestingly, on Linux, right, on Linux, though actually we can do this like several targets or something. So let me show you what I mean. While this thing is greater, we're gonna basically repeat all of that. Yeah. So that will enable you with doing something like test and x86 64. So it will simultaneously test this entire thing and also run x86 64. Yeah, perfect. This is actually super cool. And in CI, I will be able to, like for Linux specifically, not only do test, but also x86 64. And also x86 64. Oh shit, Emacs. What are you doing? x86 64. Cool. On macOS it doesn't really make much sense. On Windows it also doesn't make much sense. So we're only gonna be doing testing. So yeah, you can actually make it as complex as you want. You can parse command line arguments. You can do other stuff. Maybe we're gonna do some incremental compilation. Essentially, we're gonna have some special macros that let you check whether a particular file was modified, and if a particular file was modified, you will run a particular command so you don't rebuild everything. So we can do all sorts of interesting stuff. Yeah, and all of that is gonna be in C. We're not doing it for the sake of C, so it actually solves the whole class of problems, which I already discussed in the previous streams. Alright, so what did I do actually? So now we don't have a record. You know what kind of subcommand I forgot? By the way, it indeed works on FreeBSD. Really? That's cool. So, so we forgot help, but maybe I'm not sure how exactly to do that. I think I'm gonna edit later. Is there for each in C? No. You have to implement it yourself. All right, in README, build. Do I want to do the tests? Do you want to explain the test? Maybe not. Just a second. I need to check something. Really sorry. So we do need some sort of a help command. But to be fair, all of this stuff has to be done like after. So I'm just thinking how to organize all of that. Because I want to be able to do something like no build help, right? And it would just print you what's available there. I think that'll be actually kind of cool. So that means this kind of parsing has to be done like before here. Okay. All right. So here's the workflow. I want to do no build, help, and it doesn't do anything. But if I do build test, it will build everything and then test. But I also want to be able to do something like x86 64. But what's gonna happen if I do just like something like this? It's really strange. So it should probably do something. It's really strange. So if we encounter help in here, so essentially it will try to build first and then print help, which doesn't make any sense. Well, we can try to do something like this then. So I'm gonna put it here. So this is the command line, and if argc is greater than 0 and argv0 is equal to, well, I mean strcmp. strcmp help, right? If it's equal to help, we need to print the help. Print help. And also exit, right? We have to print help and exit. But on top of that, it would be kind of weird if you just do it like that. So that means we also have to handle it here as well. It's really strange, but I think it's... yeah, I'll think how to, you know, make it better in the future. Also records... maybe it doesn't make much sense to separate these things. Maybe it doesn't make much sense. Yeah. Yeah, I think it doesn't make much sense, so I think it has to be like separate things. If arg greater than 0, it's gonna be that. Recording will also require rebuilding everything. x86 also will require rebuilding everything. But in case of x86 64, but in case of when it's not like that, I'm gonna just do the build. Okay, so I think shift is kind of an overkill. Shift is kind of an overkill. Oh my god, Emacs. Okay. Const-char subcommand. Null. If arg c 0, it's gonna be like this. So this is essentially what we do here. And if subcommand equal to null and strcmp subcommand is help, we should print the help and exit. Print help and exit. Right. Otherwise, we should try to build everything here on Linux. Hello, Cindertable, welcome to the stream. Welcome, welcome everyone. Linux, cool. And build x86 64 example, several of them. If subcommand. Okay, so this is going to be our thing. Nice. Print help, and we don't have a print help, so let me see. Print help, and what we're gonna print here is gonna be print f. Okay, so we can actually accept this stream, right? So, and once you accept the stream, you can provide it here. So this is one. This one is gonna be std out. Print help. So we know, we guarantee that we're never gonna encounter here, so it doesn't matter. So, but furthermore, it makes sense to print help here, but into std error. That's right. So now subcommand, and we don't need x86. Well, the only thing we need here is test and record. Okay. So we have something like no build build tool chain and examples. So it's gonna be like this. Then run the tests. Capture the current output of examples as the expected one for the tests. And do we have anything else? We also have help. That's right. Help. Show this help message. There we go. Alright, so, and if I try to build this entire stuff, so it also does this thingy, no build. Okay. Not equal. Okay, cool. Alright, so it just builds. Then you can do help, and it shows you the help, build to chain examples. Then you can do test. Alright, and then you can also try record. Cool. So yeah, seems to be working. So that's our thing. And now in CI, the only thing I need to do here is this stuff. Right, so everywhere is going to be just that. Cool. Let's commit whatever we have. Did I get rid of everything? I think I got rid of everything. Remove, replace all these scripts with no build. And let's push that right into the repo. Okay, finally. So I think it works. I think it works. Another thing I forgot to actually do here is maybe mentioned to that do no build help for more information. Do no build help for more information, and in this particular case we can just do no help exe help for more information. All right, so maybe remove do. It kind of sounds dumb. Yeah, so all right, that's actually pretty cool. Mention no build help in the readme. Cool. So what do we got? What do we got? Evaluation language. The fails to use what are you talking about? What are you talking about? All right, so that's a lot of changes. Oh my god, it's 1,000. Oh my god, I wrote manually almost 1,000 lines of code. All right. Another thing, what else? I had something on my mind. But I forgot completely because I read the chat. It was something important. Yeah, so it's gonna be git ignore workflow. We need to remove all of these things. So we're gonna actually go full in and completely abandon anything but no build way of building things. We're gonna completely abandon it. Right, so we're only using no build from now on. Yep. And I think, yeah, so the root folder looks better because you just have a single program that builds everything, which is amazing in my opinion. Right, so just a single program that builds everything. We'll see how it goes. Maybe it's not going to be useful, maybe it's going to be terrible and we're never going to be using that again, but I doubt that. But yeah, so just build everything like that. You can just do it like this. Mhm. Okay. Clean up CI YAML. Right, and another thing I wanted to do, I wanted to fix the merge conflicts, alright? Fix the merge conflicts. Oh my god, Emacs. Holy sh... What the fuck is going on? Okay. What I'm trying to do here, I'm trying to merge with the master, and I want to see where exactly it's gonna fail. Alright, so... Yeah, I can see exactly where it fails and why it fails, so let me quickly do that. So essentially we don't need anything but this, right? So this is the, you know, the solution that we need. Excuse me. Oh, and also, okay, that makes sense. Wait a fucking second. Oh, alright, I see. Okay. So we have to move it here. And we don't need this thing here. printf output. Alright, it's gonna compile now. It should compile now though. Okay, another one. Come on. Another one. So we are using div-u, right? So we're using div-u. So that means here we just have to use the one with printf, but change it to div-u. I see. So let me quickly get rid of that. And now that. Similarly here, we just have to use the one with the fprintf and rename mod I to mod u. Rename mod I to mod u, and that should be enough. Okay, everything seems to be okay now. Continue. Do we still have unresolved conflict? Oh shit. Deleted by us. Well, yeah. I just deleted it, yes. Sure. How do I resolve that? Okay, wait a fucking second. Okay, I'm gonna literally delete it then. Yes. Git add build msvc bat. Okay, so yes, please continue already. Holy shit. Oh. Alright, I'm gonna try to rebuild everything one more time. On top of that, I might as well try to test everything. I think it would make sense. Tests pass, so everything's okay. I'm now happy. So let's just push that right into the repo. Okay. Cool. Epiku. That's a lot of changes. What the fuck? That's a way over my limit, but it is what it is. It isn't what it isn't. So let's just wait for continuous integration. And while we're waiting for continuous integration, chat, I need to pee. So let's do a small break. So it's gonna be 2 minutes, I think. 2 minutes and oh, maybe I'm gonna actually make 3 minutes, and I'm gonna put the kettle up as well. Right, so I'm gonna quickly make a cup of tea, like prepare my vessel with the tea leaves and whatnot. And guys, do you have any questions while I'm making tea? Right, do you have any questions? Phone number, no, this isn't the phone number. Right. No more planes, yeah. Sorry. No more planes. It is what it is. And it isn't what it isn't. Finally, peace and quiet. Is that how you say that? I'm not sure. So, no questions? Nobody has any questions? Or, I don't know. All right. So I guess no questions. It's clear for everyone. Sure. Let's make a small break then. And you guys have fun. Alright, I'm back everyone. Let's continue. Cool. Is the continuous integration done? Let me see. It is done. Let's actually check everything. So we're gonna see if everything compiles. All of the conflicts have been resolved. So here is the build. We build everything. Yeah, also including x86-64, and we'll also run the tests. And here it is. Yeah. So that's pretty pogue. And it also works on Windows. Oh my god. I cannot believe that I managed to do that. This is so cool. Officially merged. Officially merged. Okay. Now, feel free to submit your pull requests and fixes for this build system. Now, it's open for all of that. Yes. So yeah, it's pretty cool. Nice title. Built on Linux, Mac OS, FreeBSD, literally any OS on the planet Earth except Windows with MSPC. Alright, so... Yep, that's pretty cool. Okay, so my kettle is ready, so I'm gonna go quickly to the kitchen and just pour myself some hot water, and we're gonna be back. So the next thing I want to do, by the way, once we merged everything, I want this build system to be a reusable project. So I want to take this header file and extract it to a separate project. Right, so, and then we're going to extend that project in a separate repo, and we will try to keep it reusable across all of the projects that we build. So that's going to be the idea. Makes sense? Completely makes sense. Yeah. So, yeah. Build tool as a C header file. Isn't that interesting? I think it's pretty nice. Build Suwon with build.h. With no build.h. Okay, so let's go back and fetch everything. Fetch everything. So did it do the trick? I think it did. Alright, so this is how many changes we made. So how are we gonna extract all of that? So obviously it's gonna be a separate like project and whatnot. And how are we gonna test that? How are we gonna test that? I guess maybe we're gonna have like a bunch of examples that we're building and whatnot, and then running those examples, and we can build them with no build itself as well. Huh, that's pretty cool. Yeah. Yep, so that sounds interesting. Okay, I have an idea how to organize the no build project. Yeah, it's gonna be no build. And I'm gonna just copy paste no build header there. So this is the artifact, right? So that's the entire thing. So you're supposed to just take this thing and copy it to your project, and yeah. So we're gonna introduce no build.c, which includes no build.h, right? No build.h, and also starts this thing. All right, what kind of things do we want to test here? Self-hosted build system, exactly. It's a self-hosted build system. What kind of thing we want to have here? So maybe we're going to have examples here, or maybe tests. Right, so I'm going to create a folder test. And what's going to be the first thing we want to test? What's going to be the first thing we want to test? I don't know. So it depends on what we have there. It depends on what we have there. Read dear. Well, it could be something like this. For each file in directory, so it's going to be example test. So it's a multiple, let's call this examples. I think it would make a little bit more sense. So examples are the tests, examples, and then we're just like iterating over them. And depending on whether, oh yeah, we have to be actually doing that slightly differently. Build example like this. So we're gonna have a special function that builds an example. It's gonna be build example const char example, and depending on whether it's Windows or not, right? If defined Win32, we're gonna call cmd cl exec path examples example, right? Path examples example. What's interesting, CL, I think it's gonna put it in the same folder. I think it's gonna put it in the same folder as like where the source code is located, is it not? I think this is how CL works, if I remember correctly. Yeah, I think this is how it works. Otherwise, fix for Emacs macro indentation should be part of the no build repo. Probably, I don't know. I don't know why, but sure. Okay, and because of that, I want to do the following thing. So it's going to be examples, example, remove extension. Remove extension is going to be like that. So this is O, and then we're going to have something like path examples example. There we go. And then it's going to be end if win32. Cool. So so we're building the example, right? We're building the example, and on top of that, maybe we should try to run the example afterwards. Oh yes. So yeah, I'm just thinking, do I want to have a separate thing called run example, or maybe something like check example, right? Check example, and essentially what it will do, right, on Windows is gonna just run this thing like that, where it also removes the extension, right? It removes the extension, but also adds the exe, right? Also adds the exe thingy, right? And just executes it like that, just to see what's gonna happen. But on Linux, it's gonna, yeah, it's gonna do the same, but without it, right? It's gonna do the same, but without it, without the exe, right? It's gonna be like this. Right, you see, it tries to build the example and also simultaneously run it. So, and by itself, no build is already example as well. That's what makes it interesting, in my opinion. Right. So that's pretty poog. So, and it feels like that this thing is repeated several times. So we have like this thing repeated like this. So maybe because of that, we should introduce something like const char output path, right? And just put it here. And now this entire thing becomes the output path, right? And in that particular case, this could be something like concat output path dot exe. Custom indentation for macros in C. Cool, thank you, Enkatia. Thank you. I will check it out at some point, maybe. I don't know. Okay, so also output path, I think, depends, also greatly depends on the so I think it's not output path, but rather the example path. Yeah. Yeah, something like this. Okay, so, but what do we need here, actually? What do we need here? Well, we can just have separate things for separate features, like concat. I can introduce a function concat.c, which includes, by the way, nobuild.h, right, and just concatenate some things. Concat foo bar buzz. And then we're gonna have more of these kind of things, right? Okay, let's give it a try. So essentially what you should be able to do is just nobuild.c, nobuild, right, and it doesn't compile because if I got a semicolon here, right, and after that you should be able to just run this entire thing, and it iterates. So it tries to do C. Oh yeah, we need to ignore the dot folders. Yeah, I completely forgot about that. So that means if example not equal dot, we have to do it like that. All right, so let's do it like this. And it worked. There we go. So essentially now, if I add more examples into the folder, it will have more of them. But to be fair, I think having like a whole example for concatenation is kind of overkill. So what we're gonna do here, we're gonna have a string.c. Right, we're gonna have a string.c, and we're gonna introduce something like string manipulation example. So, and we're gonna just put something like this, right? Right. Concatenation. Concat. Maybe even something like. But the problem with concat, you have to like query replace this thing with that. Is equal to like this, and let's see what's gonna happen. Cool. So concat equal that. Now we can do something like path. Well, we might as well also have a macro, a special macro that stringifies everything for us. I think that would be also pretty cool. Input file is the same as output. Excuse me. Oh yeah, so we also need to only care about C files, right? So essentially we should ignore any non-C files. So if this thing not equal to dot, and if strlen, so we have to do something that says an strlen example. Okay, I'm gonna pour a cup of tea. If n is greater than 1, I think, right? And example plus n minus 1 strcmp equal to c, right? Actually, it has to be like a, yeah, it should include dot, so that means we'll have to add 2 here. Only then we're trying to check that example, right? And it didn't really work. Okay, I missed something. Greater or equal than 2. So if this thing doesn't start with that, we take a look at n. N has to be greater or equal than 2. I take n, subtract it, and okay, so equals 0. Equals 0. I keep forgetting that you need to use equals 0. Okay, cool. So now it properly compiles everything and it tests it. Nice, 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 nice. can I have some special macro that stringifies everything? So essentially, instead of writing that, I want to be able to do something like demo concat. Let's give it a try. Define demo. So here's the expression, right? So here's the expression. And what I want to do here is printf, maybe expr, like stringified, then do equals s, and then put this expression here. Right, so this is basically what I want to try to do. All right, and similarly, I want to do demo concat like twice, just because I want to. Okay, it works. So now I can do path. Perfect. You see what it does? I think it's pretty cool. Right, so this is exactly what I want to do here, and that means it lets me actually have more of these kind of things. So and then I can do something like concat with a separator, and you can put like ++ here. So here's your custom separator, and there we go. Here's your custom separator. So yeah, and as we add more and more string manipulation things, we can just add another thing here, and we'll be testing it. It's kind of cool actually. So you have build.h build system. We have nobuild.c that uses this thing, and that thing builds everything in the examples that uses nobuild.h, the level above. Right, so we have a build system that builds another build systems and run those build systems that test other things. So, and they use the same core header file. I really like that. So it's actually pretty cool in my opinion. So yeah. So it's pretty awesome. I don't know why I get a kick out of that, but it's pretty interesting. So first you bootstrap the build system, run the build system, and build system builds everything else. So you can actually have several build systems, several phases of build system that use the same build.h, no build.h. Okay, so alrighty, and so what else do we want to test? I think we tested pretty much everything. Close dir. So for each array, for each file, make dirs. Cool. We can have example for eaches. That's what we can have. Yeah. So let's actually quickly do that. Yep. I might as well git ignore. Just string here for each C, and this entire thing will just include no build.h, right? And we have several for each examples here. So for each, for variadic arguments, for each for arrays, for each for files and directory. Yes. So we want to test those. Example string. So it's going to be for each macro example. All right. So we're going to start with the variadic argument one. Right. So with the variadic argument one, how can we even do all this? Oh, what's funny is that variadic argument assumes the type, unfortunately. I think it assumes the type. Is that? Yeah, I guess that's okay. So the compiler will tell me. Don't worry about it, guys. Like, I mean, it's not a valid C, so it will. I'm not programming in JavaScript. Come on. All right. So for each vargs, and we can do something like this. Int ignore and put it like that. Okay. So va list args, and I do for each va args. What are you talking about? Nothing. Nothing. I didn't say anything about JS. Nothing. You didn't hear anything. God, chat. Chat, please hide me. Fuck. A little bit hot. Alright. So, what we're gonna do here... Okay. Whew. Now, so what we're gonna do here is gonna be like s and yeah, I'm gonna put it like that for each macro. For each the args, and I put 69, and we're gonna have foo bar buzz. But interesting thing here is that you have to null terminate it. Yes, you have to null terminate it. Arise with a fresh espresso. Sorry. Okay, so for each macro example, so this is variadic arguments. Alright. Zozin and friends on JS. C++ programmer in the presence of JS. Well, I don't know. Node.js is actually quite fast these days, so. My only problem with the JavaScript is its type system. But even that is fixed by TypeScript. But TypeScript is a third-party dependency that you have to always like bring with yourself, which is a little bit annoying. But apart from that, I think it's a pretty fast scripting language. Alright, so we have something like this. JIT compilation. Yeah, JIT compilation actually helps. It's something that Python, like CPython, doesn't have, right? And yeah. But Python is sort of like a basically example, a demonstration that maybe JIT compilation is not that important for popularity of the language. What is your favorite scripting language? Python. My favorite scripting language is Python. Yep. I like its simplicity, I like its syntax, I like its type system. I think it's a good type system for a scripting language. I don't think it's a good type system for a serious software development language, but it's a good type system for a scripting language. It's strong. It's strong. You can have any type you want as long as it's full. Yeah, sure. By the way, Hudson Plus, what is your favorite scripting language? Dennis agrees Python is very good. Well, it's not bad. Do you like Julia type system? I haven't had an opportunity to actually explore Julia's type system a little bit deeper. But I guess it's like, it's strong, right? It's very strong. I think it's stronger than Python's type system, but yet it's still dynamic. Shell script. It has a horrible type system, by the way, in my opinion. That's why I'm using C instead of Shell. One of the reasons, though. So yeah. Okay, here's the for each. So where's the another for each? So for each array. So let's define an array. Const char array. And we're gonna put it like that. Excuse me. Oh shit. You're building an alternative to CMake or Makefile. Neither of those. I'm building a completely different way of building applications. Essentially, I'm making a library, right? I'm making a library that you have to include into a file called nobuild.c, right? So you include this library like that, and then you use macros and functions from nobuild.h. Then you build this file with a compiler like this, and then you run this file, and this file builds the rest of your stuff. Well, it's not gonna build properly here, right? But if you try to do it like that, yeah, there we go. So essentially, I'm using C programming language as a scripting language for building the projects, right? And to make it easier, I have a special library that makes it easy to do that. For example, that library provides you very convenient functions to concatenate the paths with platform-specific path separators to concatenate the lines and stuff like that, and run all of that as commands. And also, you have very convenient macros to iterate over files in a folder. So yeah, so this is basically how it's done. So I'm not developing a build system, I'm developing a library with which you can make your own build system for your project. Make sense? So we don't have a ready build system for you to go. We have a library, and with that library you build your own build system. It's like Xmonad, right? Xmonad is not a window manager by itself, it's a library with which you build your own window manager. So something like that. It's a completely different approach to building projects. I'm not even sure if it's gonna succeed, so I'm just experimenting. Just experimenting. My neighbors are going fucking crazy, mate. Alright, so what I want to do, I want to introduce something like for each array. Alright, so and it's gonna be something like that. So let's introduce static const char array, right? And it's gonna be like this. It's gonna be full bar buzz. Alright. So and then we're gonna do for each array is gonna be item array, and then we're gonna just print each individual item there. Is it open? Not yet. I'm actually in the middle of process of making it open. So you've come at the right time, right? I'm in the middle of preparing the repo that I'm gonna actually upload to GitHub. So right, so the tool is so the prototype of the tool is ready. It's only a prototype, and I'm just making examples and demonstrations on how to use this thing, right? So we have an example on how to manipulate the strings, right? So you can manipulate the strings like that. We have an example on for each macros and everything. So that's what we do. So for each array, like this, let me see, and it doesn't compile because why? I think I have to provide the type of this thing. Do I have to provide the type? Yeah, I do have to provide the type. Okay, so maybe I also have to print this entire thing. So I want to do something like a demo. I'll try it out whenever it's ready. Yeah, I guess I started to develop this thing like yesterday, so but it can already build this project, right? So it can already build this project. So this is a simple virtual machine with its own assembly, right? And it has a tool chain. So these are different tools in the tool chain, and it has examples that you can build, and it also has tests. So the build script for this project is of this size, and it's completely in C, and it uses that build system, right? And what it can do, it can build toolchain, then with that toolchain it can build examples and then test those examples. That's the idea. Bye bye, heads, let's see you around. So, and look how it works. So I'm gonna go to the project, right? So let's imagine that I don't have this thing. So the first thing you have to do, you have to bootstrap the build system. So you have to do gcc no build.c. So It's as simple as that. So the idea of those scripts is that you can build them with just C compiler, without any special flags, without anything. Just run a compiler on them, and you will bootstrap the build process, and you get have an executable. Once you have an executable, you can run this executable, and that executable builds everything else for you. Okay, so we have a build folder, and we have two other folders. These executables were built by that build system. These examples were built by that build system. And on top of that, you can run no build test. And on top of building everything, it will also run the tests and to make sure that virtual machine doesn't have any problems. So we can even corrupt some of the expected outputs of the test to see if it actually breaks when you try to rebuild that. Right, and for example, yeah, test doesn't pass, and yeah, all of that is written completely in C, and it is cross-platform. This thing works on Windows as well. It works even with Microsoft Visual Studio Compiler. That's the premise of this build system. So this entire build system is just one single C header file that works pretty much anywhere. On all of the platforms that I tested it in. So it works on Linux, macOS, FreeBSD, and Windows. And yeah, this is the second day of me working on it, actually. Yeah, does it make sense? I don't know, it's kind of a weird idea that I had for a couple of years already, and I finally got around to implementing that. Maybe it's not gonna fly. F? Are we F'd? I didn't see that we F'd. Okay. All right, so let's continue. So for each, I want to have a demo here. So here's an expression, and the thing I'm gonna do just do. Zozin, what is this do while? I'm sorry. Okay, demo. I don't think it has to be like that. I can just do expr. I just wanted to pay respect. Oh, okay. So it's gonna be like that. And then we stringify this entire thing. Might as well actually stringify it like that. So... what motivates you to program every day? Depression. Programming distracts me from my depression. All right. So then I'm gonna do the expression here, something like this. Okay, let's give me. Oh, I'm actually rebuilding the wrong thing. Yep. Okay, so that seems to be working. So, and another thing is gonna be for each folder, I think. Hello from Vancouver, hello from Novosibirsk. There's a lot of warnings when compiling VM on macOS. Oh yeah, this is because of Clang. Yeah, I think I can even see those warnings. Let me try to do that with Clang. Oh shit. Okay, I will have to do it like that though. Let's do it like this. Yeah. And I'm thinking this is the warnings that you get, both on VM and no build. It's probably something with conversion, right? Did I guess it correctly? It's something with conversion. I'll have to fix it at some point. Let me see. I think I know exactly what you're talking about. I think we even have that on CI. Yep. So what exactly does it say? Place parentheses around the assignment to... Oh shit, I know. Oh my god, I know what it is. It's fucking classic. We had that yesterday on the Discord call. Yes, I know what it is. Okay. Let me quickly do that. For each. essentially, yeah, that's it. That's the whole fix. Okay, I'm gonna try to push that fix right there. Try to fix some of the Clang warnings. Push. And both try now. So will it have less warnings now? So it should have less warnings or no warnings at all. So essentially, Clang freaks out when you do assignment inside of the conditions, right? So it thinks that you made a mistake here, right? So it thinks that you like forgot to add another equals, but sometimes this is exactly what you mean. And basically Clang requires you to add extra parentheses to confirm that you know what you're doing. So, and that's why it spits out this kind of warnings, which is kind of, by the way, useful in my opinion. I think it's useful. So basically you have to confirm, yes, I know what I'm doing. This is exactly what I mean here. And that's exactly what we do in the no build. So. Okay, so BM still has some. Okay, thank you. So let me see. I wonder where. Do I have... I think it could be something about the conversion. macOS. Okay, let's go here. Yeah. I see. Conversion warnings. All right, let me take a look. 1037. Holy shit, that's a big program. All right, 37. Okay. Program size. Format specified s size aka long, but the argument is uint64. Really? Program size in our case is uint64? Oh yes, it is. Okay, that's actually a very useful warning. I just realized. Okay, thank you, Anaboso-sama, for actually bringing my attention to that. Yes. GlanDuolingo has different warnings than macOS. I also have a very old version, so that's another thing. So you know what I'm gonna do? I'm gonna add conversion. I think I already have conversion, that's the thing. Alright, so build. On CI is the same. Ah, okay. So we're gonna put it like this. It's gonna be PRI U64. So this is a PRI U64 and so does it have anything else? 3730. Okay, so this is the whole thing apparently. Let's do the tests. Cool. Try to fix the conversion warnings on Clang Mac OS. Anaboso, try now. Should be 0 warnings, hopefully. I don't know. It's not technically conversion. I don't know. Maybe. But it's better to match the expected types appropriately. Anyway, just in case. Oh, by the way, what's up, Yellow? How are you doing? Really good to see you. Clang 12. Just wondering about conversion. Yeah, 0 work. Thank you so much. Yeah, good work. Remote debugging. Nice. And thank you so much for helping me to get rid of the warnings. Yeah. Thank you. That's cool. No build. So, and I think I also need to do the same thing here. It's gonna be for each file. We probably need some sort of like a Tsojing dab emote, but I have no idea how to pull that off. Yeah, it's 1070 lines, and I wrote them all by hand over the course like 12 days, I think, and yeah, a lot of wasted time. A lot of wasted time. Alrighty. But yeah, I'm surprised this entire shit works. Holy shit. What the fuck? I remember my times of working at like Java Enterprise. And the technology in that area is so fragile. I got used to things never working first try ever. And I'm programming in C, C++ on like, you know, on the smaller projects, and it just surprised me every time. Like, why does it work first try? Why there is no like some sort of a pitfall that fucks you in the ass every time you try to do very obvious things? Like, why? It's like I still cannot get used to that, unfortunately. Like I just got used to that nothing ever works first try. That's why I react like that. 12 days to write 17. Okay, let me see. So how many lines per day? Well, I mean, 141 lines per day, that's like a weekly norm of an enterprise developer. It's actually more than weekly norm of an enterprise developer because it's usually like 100 lines per week. So I think it's good. Yeah, I think it's good, in my opinion. Alright, so I wrote a total of 1 line today at work. Nice. I think it's cool. You know why? Because you're gonna get paid at the end of the month anyway. So that's why it's cool. Well, I love office job. Trust me. It's so fucking awesome. Yeah. Because the job is not measured by amount of lines. Cool. So what I was doing, okay, for each, right? So we have for each array, and another thing I want to test is for each file in dir, and we're gonna accept the directory. So we const char dir path. Yep. For each file in directory, so it's gonna be file dir path, and we're gonna put it like that, and we're gonna simply do it like this. File, yeah, it's gonna be simplify. Simplifile. It's a something that simplifies everything. Simplifile. Anyway, it was not funny. I'm sorry. So for each file in the array, it's gonna be like that. All right. So look at that. That's pretty cool. Right. So we have tests for each of our args, and it prints as that. Then we have for each array, it prints as that. And lover of simple, simplify. Okay, it's like header file, right? It's a person who loves headers. Header file. Right. So header file. Anyway, so do we have any other for each macros that we need to test? This is so dumb, I'm sorry. Okay. So I guess that's pretty much a whole dot file. Oh shit. That's the whole thing. Oh, we also forgot to test the remove extension. Yeah. So I'm gonna go to the string. String.c. Do you know about Biscuit YouTube channel? Yes, I do know about him, and I really like his channel. I think it's super cool. Oh, not... Yeah. So with Q and W, yeah, I know about him. He's doing like a lot of retro coding and stuff, and yeah, his videos are amazing, I think. I think we even watched some of his videos on this channel. Yeah, we watched a lot of his videos. Yeah. All right. So let's try the following thing. It's going to be demo, remove extension. It's going to be main C. All right. I don't know. So remove ext.c equal just main. Pretty cool. Oh, right. So for each. So the last example should test the CMD functionality, right? The thing that runs external commands. And how are we going to test all of that? That's a good question. I don't know. We already kind of tested with build.c here, but it's not part of the examples. That's the problem. It's not part of the examples. We can try to run some of these examples here. Right. Okay, so cmd.c, it includes nobuild.h. And what we're trying to run here, we're trying to run. What are we trying to run though? We can try to just run echo hello world. Maybe something like this, but I'm not sure if it's a good idea generally. You know what, I'm not gonna have this example because it doesn't really make any sense. Right, so the main example is build.c, right? So it shows you how to iterate and actually call other things here. And from within those other things, we have demonstrations of different like macros and whatnot, and string manipulations that are very useful. And also let me git ignore no build, and oh, yeah, we're good to go. Yep. So that's pretty cool. That's pretty cool. All right. So the time has come to add the license, right? The license is gonna be, of course, MIT, and also we're gonna have readme md, no build. So build tool. How to explain that? So I need to come up with an elevator pitch, right? Do you guys know what is an elevator pitch? Do you build no build in no build, or is it just a header file? Okay, so header file is the library that you're supposed to use. So it's our thing. No build.c is your thing that utilizes no build.h to build your specific project. Right, so within nobuild.c you have main entry point, and you use the function from nobuild.h to run external commands and whatnot. Right. So the first thing you do to start building, you bootstrap the build system. You bootstrap in the build system by just building this thing like this, nobuild.c. So the idea is that you don't have to use any special flags or anything. You should be able to just build this file with just the compiler. Right. And on Windows, for example, it should also work by doing something like cl.exe. So it should also work. That's the premise. Once you bootstrapped your build system, you can run this build system and it builds everything else. So this is how it works. Yeah. Make sense? So on BM, I think on BM it's a little bit more impressive because it does a lot of different things, right? So this is what it does on BM. It builds the whole tool chain, then it builds all the examples, and then it builds x86-64. You also can run the tests and whatnot. I think it's pretty cool. Header-only library to support you writing your build recipes in C. Recipes. Recipe is not a bad word, I guess, because I was using word. I was using word script, which is technically incorrect. Maybe. All right. Build. Maybe a header only library to support. Maybe for writing build recipes in C. Okay, so that's pretty much the elevator pitch. Usage. First, copy build.h, no build.h, to your project. Create no build.c in your project. With the build recipe. C our own no build.c for an example. Bootstrap the no build executable. Create your own build system. Yes. Remove everything, create your own build system. Alright, so it's gonna be like GCC, or maybe just CC. CCO no build.c on POSIX systems. cl.exe no build.c on Windows with MSVC. Run the build. Sure. Cool. Run the build, and it's gonna be like this. No build. Yeah, like this. Thanks, you're welcome. Cool. So that's pretty much it. Do I need anything else? Yeah, so that looks good to me. So maybe I also want to explain the reasoning behind all of that. Okay. Main idea. The idea is that you should not need anything but a C compiler to build a C project. No make, no CMake, no shell, no CMD, no PowerShell, etc. Only C compiler. So with the C compiler, you bootstrap your build system, and then you use the build system to build everything else. Right. It is that you should not need anything but a C compiler to build a C project. No make, no CMake, no shell, no CMD, no PowerShell, etc. Only C compiler. So with the C compiler, you bootstrap your build system, and then you use the build system to build everything else. So try it out. How to use the library in your own project, right? So it's something like this. Try it out right here. cc no build.c oh no build. No build. Check out no build.c file and the remove the comma after. Okay. Oh yeah, that makes sense. And the examples folder. Yeah. Also, maybe something like explore to learn more. How to use the library in your own project. Copy.h to your project. Create build.c in your. Oh, holy shit. See our own build for an example. Bootstrap the build. Like that around the build. Okay, I think that's cool. So do we need anything else? Oh, we don't even have anything. The Git repo. Let's initialize everything and let's commit everything. Yep. All right. For each. After more. Okay. I don't know why I keep adding those A's. Maybe there's something wrong with my keyboard. All right. Thank you so much. All right. Wait a second. I think I also want to simultaneously add all of the building stuff as well. So I'm gonna copy paste .git in here. Yep. All right. So it's gonna be .github. I mean .github, not .git. So we don't need this thing. I'm gonna have build. So of course we want to do it like that. And just execute no build. So the same thing will go for Clang in Linux. Clang in Linux and so it's gonna be like this. macOS. It's just that, and Windows. All right. So we also need to remove this kind of stuff. Cool. Ready, set, go. All right, and now I need to create the repo where I'm gonna push all that. Single header and not header only. Third time. What? Excuse me. No build. All right. So header only library for writing build recipes in C is going to be public, and let's push that right into the repo. Let's push that. So I'm gonna grab this thing here and add origin. And so keep in mind that this is a prototype that I hacked together in like 2 days, right? So it's not meant to be like a complete project or anything like that, but maybe this is something that I have to mention in the project itself. All right, so yep, check it out here, boys and girls. Check it out here. Finally, no build has been officially released. Isn't that amazing? So we probably need to wait for a continuous integration. Hopefully it will start soon. Yeah. Use it on your $1 billion software, sure. That's exactly why I created it. Alrighty, that's amazing. So let's take a look at the build. So on Linux, it built successfully, and on Windows it failed. Of course. I'm so happy. Could not start child, no such file or directory. Shit. Fuck. Okay, so I think I need to put executables, like I need to specify where I'm gonna put the executables. Thank you, Windows. Very cool. We're starting this process all over again. My favorite. Alright. No build.c. So I remember what I have to do here. So I have to specify that executables go there. Right, executables go there. So it's gonna be like this. I guess examples Yeah. Hmm. Hmm. Okay. Specify the executables path for MSVC build. Right, so maybe that will work. All right, let's see if it helps. Let's see if it helps. Okay. Windows. Okay. He'll send request to Linux, change Linux build system to use no build. I don't think he will acknowledge that at all. So maybe he will. Who knows? I'm looking at the wrong shit. I'm sorry. Isn't like build system of Linux is actually like custom and very complicated and shit? I think it is. Okay, now it works. And it seems to be, yeah. Yes, it's supposed to preprint dot and dot dot. It's a huge makefile, I see. But it also probably glues together a shit ton of different like other tools and whatnot. Yeah. That's expected. And it also puts objects in the current folder. It's fucking classic. But apart from that, everything seems to be working. Everything seems to be working. Nice. Cool. So, yeah. I think I'm gonna make a small break before we continue. So I need to actually decide what we're gonna do next. I think I'm gonna just continue working on virtual machine. Yeah, because we have a lot of pull requests in the virtual machine, so I need to go through them. Right, so I'm gonna make a small break for like 2 minutes, I think, maybe even 3 minutes, just in case. And after the break, we're gonna continue working on all of that. The colors are all weird. This is because it's a C mod. It thinks that this is a type and this is a variable, because in C you oh it thinks it's a it thinks it's a function. C mod thinks it's a function, so it recognized it as a type, function name, and this is the arguments, and that's why it's colored like that. You see, if you compare it like this, it's you would never think that this is a more or less valid function C definition. So, yeah. Well, this one is not valid though. Okay. So, all right, let's make a small break, boys and girls, and you guys have fun. Yo, I'm back. Too back. Alrighty. So what we got? What do we got? Do we get any interesting pull requests? Alright, so we're gonna start from the bottom, right? Because in the order of their arrival. So maybe it also makes sense to change the title, because we're not working on the build system anymore. So what we're gonna change it to virtual machine in C. Alright, so let's call it code review. Maybe not. Maybe it's okay. Whatever. So yeah. So as part of our toolchain in virtual machine, we have a debugger which was developed by Hotzenplotz, Nico, and yeah, he usually submits different pull requests and modifications to the debugger. And here's one of them. So implement repeating the previous command, right? So essentially, yeah. So this is how you're supposed to be using it. Let me try to do that. No build.c, and let me rebuild everything here. Let's see how it goes. Right. So you can just try to execute one of the examples that you compiled here, like this. Right, and it just runs it and generates Fibonacci sequence. But you can also try to debug it, right? You can break on main, right, and run this entire thing, and then just step debug it. But the problem is it doesn't repeat the previous command on enter like GDB, which sometimes is not particularly convenient, right? And so this is Nico. This is what Nico implemented in this particular pull request. That's a lot of changes for it. Okay. So it fixes 94. If you have any issues with this implementation, please let me know. Okay, that's very promising. Let me see. Let me see what could be wrong here. Input capacity. Okay. So he extracted running the commands into a separate functions. Okay. All right. That's probably why we have so many changes here. So we have input capacity. Right. Oh, I see how he implemented it. Okay, so he extracted running the command into a separate function, so he could repeat that command on just enter. So you can basically cache what command was executed as a string, and you can just repeat that. That's actually a pretty good solution, I think. Let me see. So I think I need to fetch his changes. So let's fetch all of the remotes. Let's fetch all of the remotes. All right, and it's the issue 94. So let's create it here. And again, so I already demonstrated that it doesn't work that easily. Oh shit. Yeah, I know what it is. So yeah, so it's from the times when the bosom to NASM wasn't redirecting it to anything. I see. So all right, let me try to run this thing one more time. I'm gonna break on main, and now if I run this entire thing and do n, I can now press enter and it repeats the previous command. Cool. So let me see if it is implemented properly. So let me see how it is implemented. So we have a loop. Here's the input. We grab the input. So if it is enter, store the previous command for repeating it. So previous command. Check. Here it is. Check if we need to repeat the previous command. So essentially, we are repeating the previous command when the input is empty. Essentially, yes, when the control world. Okay, that's a reasonable solution and it's easy to understand. I think it's a good solution. So I'm gonna just merge it. Yeah. So just basically store the string and repeat the string. So it's like as good as it can get. I don't see any problems with that. Looks good to me. +1. Thank you for your contribution. Boom. And let's merge that pull request. Absolutely. Fucking epic, mate. Thank you, thank you, thank you. That is amazing. Alrighty. So let me go to the master and fetch the latest stuff. What if we didn't enter anything? No previous command. So he takes that into account. He's a smart developer. I didn't think you can outsmart Nico himself. Alright, so looks good. No build. So I think I also gonna do this thing like that. There we go. So we're gonna rebuild everything. And maybe it also makes sense to test everything just in case. Why not? And next pull request. BMR error. Error allocating static memory on... Yeah, I know what it's all about. Yes. This is because I have too much static memory in BMR. And yeah, so I'm gonna just, mark it as red because I'm gonna fix it at some point. So add build x86-64 example on Windows. Oh shit. So yeah, edit format flag to BOSM to... Oh my god, I'm so sorry, Columb. No, I'm not sure. And I think this needs to be scrapped, so I don't think it can be salvaged at this point, so yeah, I'm sorry. I'm really sorry, so feel free to close it. It's too many things have changed and stuff like that, and I need to think how no build is gonna download the dependencies. So, well, yeah, no build can just run curl and whatnot, but I mean, it's also kind of... yeah, I'm sorry. So I'm gonna close it. I'm gonna just close it. I'm sorry. Also, this entire... I would recommend anyone who wants to contribute not to touch BOSM to NASM functionality, because it's very much experimental and I don't have enough information to know how to implement things there. I'm just experimenting. You're in the middle of the experiment and trying to put something there just doesn't make any sense. Yeah, so okay. So we have that. BDB symbol tables do not distinguish between labels, constants and natives. Alright, so this is the result of the now obsolete bind directive. When reading in, BDB would add labels. Yeah. So this is another thing that needs to be done, and I think that is it. We addressed all of the pull requests, I think. Let me see. BM, and yeah, I think everything is done. Yes. Cool. So we can start working on some of the issues. I'm not sure if I'm gonna start working on some issues. I feel a little bit tired already, and it's not even 4 hours in. Maybe if I pick something very simple, I can make it work. But I know. We'll see. Error allocating static memory on AArch64. There's no script to run tests on Windows. All right. So let's work on this thing. Error allocating static memory on AArch64. So essentially, the reason why it happens is because in BMR we have too much static memory. Let me see where we allocate this memory. So basically we have arena. So this is first arena that allocates 1 GB of static memory. So this is what it does. Another arena allocates another gigabyte of static memory. Right, and if we use BOSM, I think we don't use BOSM, but maybe in BM, the context. In the context, let me take a look at the BM. So it's a struct BM. It does allocate like additional memory. So the size of BM context itself is also quite big. But I'm not sure if it could be even bigger. All right, so So right now it should actually not fail. Welcome back, Adnan. Hello. But this is not a proper solution. The only thing I did, I just reduced the size of the arena, and I don't think it's a proper solution. A proper solution would be creating like a proper arena or whatnot. But I don't think I want to work on that right now. All right, so let me actually put it this way. I'm gonna ping here some plots. I reduced the size of the arena structure. Does it make the problem go away? I know that it is not a proper solution. And then that's not a proper solution. Just wanna know if it's... Just wanna confirm that it's related. There we go. So here is that. Allocated static memory, remove the natives from the list of standard natives. We could try to do that. Oh, there is no... Oh, by the way, this is automatically fixed by using no build. Holy shit. Yes, this is automatic. Yeah, it's just automatically built. Both of them, by the way. This is the class of problems I was talking about. Right. So, and we even run them, right? We even run all of that on the CI. So, and we don't need to implement anything anymore, right? Because it just works. C works on all of the platforms, and there you go. So here are the tests running on Windows, and yeah, we confirm that. That's amazing. So we can close both of these issues now as, you know, resolved by that pull request. So what was the pull request? Introduce initial, yeah, 156. Resolved by 156. Close that. Then resolved by 156. And I forgot to close it, but I can close it here. Sure. That one is closed, that one is closed. Perfect. Yes, the whole class of problems is eliminated. I'm pretty sure we created another class of problems, but I mean... we're about to find out what kind of class of problems we created, so we don't really have that much information about that. Wasm to wasm, wasm to nasm, DB symbols. I think I want to work on this one. Remove dead natives from the list of the standard natives. Yeah, dead natives as the one. Also change. So what I'm talking about is that in the standard library we have these natives. So load standard natives. There we go. So none of these things are used actually. So none of them are useful. And the only native we use right now is write native, and I think it only makes sense to make it 0. Right, and the way we're gonna do that actually, we're gonna remove this entire stuff and just call it 0. And then in the examples, we're going to natives, right? So these are natives, and I'm gonna rename it to just 0. There we go. So that's exactly what we need to do here. Even alloc, we just don't have alloc. So, all right. So we're building everything. So building examples, not supported native. No, okay, that's cool. So that means this one has to be 0, and this entire thing, by the way, is not needed anymore. So native write is 0. Do we have anything else? Cool. Now if I try to test that as well. So let's actually try to test. Okay. Error null native. Oh, this is because BMR. Yeah, it uses like this. Alright, so I might as well actually do something like BM push native. Then I can provide BM, and I just gonna push BMR as a native, and it's gonna be 0. So this is what we're gonna have here, and we build everything here. Yep, and everything compiles and everything works. That's fucking amazing. Cool. I really like that we have some test system that I can just test everything simultaneously. Alright, and in here, I also need to remove this thing, because that's exactly what I fixed here. Amazing. Wait a second. So the issue was 152. Remove dead natives from the list of standard natives. Right, and maybe it makes sense for me to actually mark it 152. And let's push that right into the repo, and we're about to create the pull request. Yes. Yesu. Kawaii desu. Okay, 152. Wait a second, there is a new notification. You've got mail. Okay, so was skill in here, Minji. There might be update. Okay. Thank you for reminding me about that. I'm gonna use this notification for to not forget to update contribution policy. Thank you so much. All right, so I'm waiting for the continuous integration. So I removed more code than I added, which is amazing. So I renamed all of this stuff here. There's a lot of changes going on in this project. I really apologize for all of the changes. I do realize that it's kind of difficult to follow this project, and especially to contribute this project, because all shit like constantly changing and everything, right? But that's kind of the point of this project. I want to experiment with shit. I want to experiment with this shit, so I really apologize for all of the like very extreme changes. Like one day we were using makefiles, then we got rid of the makefiles, and now we're using shell scripts, and now we get rid of the shell scripts, and now we're using C, like literal C programs and shit. So it's fucking crazy, but yeah, I'm sorry. I know that it's fucking crazy. I think I'm going crazy. Anyway, so what else do we have here? A semicolon in the middle of the lerp BM. Yeah, this one is weird, but I'm not sure if I'll have enough energy to solve that. Constant folding, language server. Let me take a look at the issues from the bottom, right? Yeah. All right. So I think today's stream was pretty productive, right? I think I'm gonna call it a day. We did a good job. We finally finished the no build prototype, and we even extracted it to a separate project, right? You can check out this prototype here. Feel free to test it out, right? So yeah, there's an explanation here on what's the main idea, how to use all of that. There's examples that you can play with and stuff like that. Yeah, I think today's stream was kind of cool. It was kind of cool, not gonna lie. But thank you everyone who's watching right now. I really appreciate it. Have a good one, and I see you all tomorrow. Tomorrow we're gonna do Advent of Code in Haskell. Join tomorrow to support me for a moral support, please, because I'm gonna be suffering. Yes, I see you all tomorrow. We're gonna do Advent of Code and Haskell. We're gonna try to tackle day 11. I don't know how well it's gonna go, but I'm gonna do my best. So yeah, also check out our WOTS channel for recordings of the streams. We upload recordings of the streams, but tomorrow this stream is going to be there also tomorrow. And also check out our Discord server for offline discussion with the community. So yeah, thanks everyone for watching today. Love you. Mwah.